Hello, welcome back to the channel. So let's continue our discussion on convergence tests. And now in this video, let's cover a new test which will help us evaluate whether a definite integral converges or diverges using a different approach than the comparison method that we covered in the last videos. So this method is known as the limit comparison test, and it is basically similar to the comparison test. The only thing which is different is this time we'll use limits in order to evaluate, in order to check whether a definite integral converges or diverges, which is different from the approach that we used to follow in the comparison test, where we used to compare two functions based on the inequalities, right? So again, this discussion will be divided into two videos. In this video, we'll cover the concept of limit comparison test, and in the next video, we'll use the limit comparison test in order to check whether this integral converges or diverges. So now what we mean by the limit comparison test is, again, we'll start with the constants and the functions definitions. So let a be a real number which lies between minus infinity and infinity, and f and g be functions which are defined and continuous for all values of x greater than equal to a. So all values of x for which you are calculating the definite integral for, right? And again, in this case, we'll assume that our g of x, which is the second function that we'll assume, is always greater than equal to 0 for all values of x greater than equal to a, for all values of x for which you're calculating the definite integral for, right? So now, if you want to check whether your f of x dx integral from x equals a to x equals infinity converges or diverges, you'll again come up with a second function which is similar to the approach which you followed in the comparison test. So you'll come up with a second function, and usually in these type of questions, the second function guess is basically the behavior of f of x for large values of x. So whatever behavior our f of x will show for large values of x, we will consider that function, that behavior function, as our g of x. Don't worry if that seems confusing. We'll cover this concept in the next video when we'll evaluate whether this integral converges or diverges. So now, after you have assumed your g of x function, and also you have to check whether your g of x is always greater than equal to 0 for all values of x greater than equal to a, the same values for which you're calculating the definite integral for. So now you know that whenever you assume your second function, you always know about your second function, whether your second function diverges or converges. So again, there are two cases. If you know that your g of x dx integral, the definite integral with the same endpoints, converges, and also the limit for this expression exists, then you can clearly specify that your f of x dx with the same endpoints will also converge. So that is the first case which will help you check whether your f of x dx integral converges. The second case is if you know that your g of x dx integral diverges for the same endpoints, and this limit, the same limit which you calculated in the first expression, if you know that this limit exists but is non-zero, but is not equal to 0, then you can clearly specify that your f of x dx integral with the same endpoints will diverge. So these are the two cases that you can totally use in order to check whether your f of x dx integral converges or diverges using the limiting comparison test in these type of questions. And again, you have to note that in part B, this limit must exist and also must be non-zero, while in A we only require the limit to exist. So this limit can also be equal to 0. There is no condition for this limit to be non-zero in order to evaluate, in order to check whether your f of x dx converges, right? So that is the point that you should totally consider while evaluating these limit expressions over here. Again, don't worry, we'll solve different questions on all these cases which will help you identify whether your integral diverges or converges based on the limiting comparison test. So that's it for this video. In this video, we covered the concept of limiting comparison test, and in the next video, we will use this test in order to evaluate whether this integral converges or diverges based on the limiting comparison test. So stay tuned for that, and also feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.